Okay, Assalamualaikum warahmatullahi wabarakatuh. So we meet again for Chapter 3, PST371, Plastic Fabrication. So in this chapter, basically we will learn about the injection molding process and types of injection molding that are available in our industry and markets. Okay, before I go further, this is some of the info or some of the subchapter might be slightly related to PST313, which is the polymer machinery. Okay, but here we will focus more on the processings that involve in fabricating of polymeric material. Okay. Okay, the learning outcomes for this chapter is actually to state the main raw material used in injection molding. Okay, identify all types of injection molding machine, describe the concept, working principle of injection molding machine, explain the injection molding cycle and optimization, discuss the injection molding defect, causes and remedies, and finally discuss the developments of injection molding process. So basically the learning outcome here six learning outcomes will be further divided by 2 sessions. So today I might share the first parts of the injection molding. Later on I will share another videos that continuities from this chapter. So I think by now all of you are already aware how the injection mold actually looks like. For those who can remember, this is the actual injection molding that we have: hopper, the injection unit having a screw, barrel, etc. And the most important part is the clamping unit that having a mold that have a specific cavity to produce a final parts or desired shapes of your component. Okay, some introduction. Injection molding is manufacturing process for producing parts from both thermoplastic and thermostatic plastic material. After a product is designed, usually by industrial designer or engineer, molds made by a mold maker or tool maker from metal, usually either steel or aluminium, and precision machine to form a features of desired part. And the material is fed into a heated barrel, mixed and forced into a mold cavity where it cooled and hardened to a configuration of mold cavity. Injection molding is widely used for manufacturing a variety of parts, from the smallest component to entire body panel of car. Injection molding is the most common method of production, with some commonly made items including bottle cap and outer finish. And bear in mind, injection molding is not only limited for polymeric material. There is other industries such as metal, ceramic, even food that use the injection molding. So this is very good knowledge for you to be to gain and to master, because eventually when you go to industry, you might want to penetrate some of the industry that using the injection molding, but they might use a different material. Although different material may require different parameters, but basically the whole process of injection molding is almost similar. Okay, so advantage of injection molding, including the complete fillings of mold cavity, is ensured easy feeding, cost saving, and high quality and product output, uniform curing, and variable thickness. Injection molding is used to create many things such as wire spool, packaging, bottle cap, automotive parts, components, Game Boy, pocket, etc. And storage container, mechanical part, including gears and most other plastic products available today. Injection molding is the most common modern method of manufacturing plastic part, in idea producing high volume and some objects. Okay. Here, I would love to mention about the capability of injection molding. Almost all of the equipment that producing different parts of polymeric material are capable of being producing using injection molding. The difference is some of the process might be slightly difficult when you compare with other types of machinery. But bear in mind, the injection molding also capable producing the parts that require a specific equipment, such as hollow parts that usually you use rotational molding. Injection molding also capable doing so, and then some of the thermoset process also capable being using injection molding, etc. Later on we will go through what type of injection molding available in industry and how they actually function and what types of product they usually produce. Okay, this is some of the common parts. I think by now you're very familiar products that been used in injection molding. This solution including the thermosets materials, combinations of even composites material itself. And then we have huge component of household equipment, and then we have electronic devices, casing, and etc. Okay, this as I mentioned earlier, the various type of injection molding process. We will go through each of these, although I might not explain in detail each of the process, but I want to introduce what type of injection molding that available in industry, because some of the process is similar to each other. The different might probably during the mixing, during the extrusion, during the injection or during the compaction, and etc. Okay, the first one is ram or plunger injection molding. We have single screw injection molding. This one is very common and very popular injection molding. And then we have gas assist injection molding, co-injection, or we call the sandwich molding, fusible loss core injection molding, injection compression, live feed injection, low pressure injection, push-pull injection molding of reactive materials, and finally Lamella micro layer injection molding. And nowadays, this type of injection molding sometimes combined together in order to produce a desired part or desired component that being demanded by end user. Okay, this is the illustration of ram or plunger injection molding. Plunger type injection molding can be a vertical or horizontal plunger type injection molding. So here we have vertical, which is usually rely strongly on the gravitational force, whereas the horizontal usually depends on the plunger pressure itself. Here's the illustrations of the ram plunger injection molding. Okay, the difference of this ram plunger injection molding, they usually don't have a screw. But modern ram or plunger injection molding, sometimes they have a screw, but the groove slightly not details. Okay, the functions of the plunger actually to force the material to go through the sprue and fill the cavity itself. Okay, that's the only purpose or the functions of the plunger injection molding. So please bear in mind, the most important parts of difference of ram or plunger with screw injection molding, conventional injection molding, is they not having a screw. Usually this type of ram or plunger injection molding having a poor mixing capability, or what we call that, if you're using more additive in that your compound. And then this is very common, single screw injection molding. I think you're very familiar with this one. You have a hopper, and then you have barrel, single screw. Okay, you can have multiple screw too, but here is the single screw having a nozzle, and when we have a mold, a tie bar to guide the movements of the mold half, and etc. And then we have gas assist injection molding. Here, the injection molding also not having a screw, but instead they have a gas inlet port, okay, to control the flow of the material and to force the material to flow from the barrel itself. Okay. And then we have the co-injection or sandwich molding. Okay, what is sandwich molding? When we say the sandwich, there is other material that being held together or being what we call that, put to coat the main material itself. So if you see the actual material over here, there is a metal insert and being coated by polymeric material. The co-injection molding usually used to introduce the skin layer into a core layer using a single machine. So usually being used to protect electronic devices from having any contact with any other metal surface, so that we don't want to have any electrical circuits distortion during the process. Okay, and then we have fusible loss co-injection molding. Okay, the purpose of this fusible loss co-injection molding usually to produce a hollow parts. Okay, as we know, last semester I did teach you about the polymer machinery. The common equipment that being used to produce what we call the hollow parts is a rotational molding. Okay, here in injection molding we can also produce a hollow parts, but the process slightly different, whereas you need to have a fusible core as an insert. Okay, and then you will coat the material, which is in this case is plastic material, on the fusible core, and then you immerse it in the hot bath to melt the core. As the core is melted, you will produce a hollow parts. Okay. And then we have an injection compression molding. What's injection compression molding? Is involve the injection and the compression process in one machine. So here, the illustration from the right side, top right side image, you can see the mold is not tightly closed. There is some gap between the two mold half, the male and female cavity. And then when you introduce the injected material into the cavity, and then you introduce the pressure to compress the molten polymer into a cavity, and finally you open and release the part. Okay, usually for injection compression molding, used to produce article or components that needs denser material or need high compaction. So usually you inject excessive material and then you press it with high pressure to provide some compaction. Next is live feed injection molding. Live feed injection molding process apply oscillating pressure that multiple polymer entrance to cause the melt to oscillate, as shown in the illustration below. Okay, if you can see here, later on I will explain the illustration. The action of the piston keep the material in the gates molten while different layers of molecular or fiber orientation are being built up in the mold due to the solidification. This process provides a means of making simple or complex parts that are free from void, crack, seams, mark, and well-lined defect. Okay. It is similar to a single screw injection molding, but having a live feed or piston that control the flow of the material. For example, when this piston on the top side move upward, they allow the material to fill the cavity. Okay, allow the raw material to fill the cavity with the direction from top to bottom, and then when it closes, the other piston from the bottom will move upward and allow the material to fill from the reverse direction from the first layer. And this process repeated until the article fill with the desired thickness of the raw material. By having this different arrangement of the fiber orientation or raw material or molecular arrangement, they provide more stronger material in both directions and avoid from any defects such as a void, crack, seam mark, and well-lined defect. And usually, these types of live feed injection molding being used to produce thick article. Okay, they fill layer by layer until all of the layer being filled and desired thickness are produced. Then we have a low pressure injection molding. Low pressure injection molding is essentially an optional extension of conventional injection molding. Low pressure can be achieved by properly programming the screw revolution per minute, hydraulic back pressure, and screw speed to control the mag temperature and the injection speed. Also make use of generous gate size or a number of valve kit that open and close sequentially to reduce the flow length. The packing stage is eliminated with generally slow and controlled injection speed. The benefit of low pressure injection molding include a reduction of clamp force tarnish requirement, less costly mold and presses, and low stress in molded part. Okay, there is some advantage of the low pressure injection molding. Some of the article require stress-free article, so you might want to consider using the low pressure injection molding. Although the process slightly longer and time consuming, but the end product will have a better quality in terms of the performance. And then we have push-pull injection molding. Okay, push-pull injection molding process use a conventional two-component injection system and two-gate mold to force metal to flow back and forth between the master injection into a secondary injection as shown below. This process eliminates wear line, void, crack, contour, and fiber orientation. Okay, this push-pull injection molding is slightly similar to the live fit injection molding. The difference is they having a two injection molding, which is the master screw and the companion screw. And when they move forward, when the master screw move forward, allow the material to fill the cavity, the companion screw will move backward. And vice versa, when the companion screw move forward, the master screw will move backward and allow another layer with different direction to fill the cavity. That's why we call the push-pull injection molding. Next, we have the injection molding of reactive material. Two reactive material are injected into a closed mold. They polymerize and set to final shapes within the mold. Okay, some of the polymeric material need a hardener to promote curing. This is usually being held or being used for thermoset material such as the epoxy material. So when both mixture, the epoxies and the curing agent mix together and fill the mold cavity, it will solidify. Okay, very simple process. They eliminate the process of the what we call the hinge layup technique. Okay. Next, we have a Lamella micro layer injection molding. This process uses a feed block and layer multiplier to combine melt stream from dual injection cylinder. It produces part from multiple resin in distinct micro layer, as shown below. Combining different resin in a layer structure enhance a number of properties such as gas barrier properties, dimensional stability, heat resistance, optical clarity. Okay, for Lamella injection molding, they have two types, two unit of injection. Okay, injection units, and each of the injection having a different material. And when each of the injection unit inject the raw material into a cavity, they introduce different properties because of the material itself, and it will inject with another injection cylinder. The second injection cylinder we call the B injection to introduce another layer. Having these types of injection molding can introduce different properties in one final article. So such as the gas barrier property usually used for protects any food packaging, some sort of medications, and then dimensional stability to introduce some of the material have high. Some of polymeric material having higher shrinkage. When you introduce different layers of material, they promote more dimensional stability. Some of the material may promote heat resistance and optical clarity. Okay, typical material used for injection molding. This is very common, such as the commodity plastic itself, polystyrene, low cost, lacking in strength and longevity of the material. ABS, acrylonitrile-butadiene styrene, or acrylonitrile-butadiene styrene itself, a mixture of compound used for everything from Lego parts to electronic housings. And then we have polyamide or nylon. The chemical resistant, heat resistant, tough and flexible, used for comps, etc. And then we have very common material, which is propylene, polyethylene, and plastic reinforced with short fiber. Okay, some of the composites material also can be injected into a cavity using injection molding. And some notes here, material used in pellet, powder or granule. Usually for injection molding, it's very versatile. It can be any types of shapes of raw material itself. Nowadays, injection molding is the most used method in producing plastic parts in different kinds of polymeric material. Injection molding is suitable processing method for following materials such as thermoplastic, elastomeric material, rubber, thermoset, the composite, and the foams plastic. The most used material are thermoplastic itself. Okay. Because each of the other material such as elastomer, rubber, thermoset having their own equipment. Okay, although injection molding also capable of producing the same article with injection molding. Okay, the working principle of the injection molding. The polymer feedstock is melted by external and internal shear heating and is forced under high pressure into a mold, which is held tightly closed, where shape stability is achieved by cooling thermoplastic or by chemical cross-linking thermosetting plastic. The suitably designed injection mold is constructed to allow the parts to be shaped, consolidated, then eject into the ends of the molding process. This is the basic working principle of injection molding itself. This is the illustration of injection molding in our labs. Okay, small injection molding shows A is a movable guide, hydraulic ram, movable platen, die, fixed platen. B is hydraulic pressure gauge, a product acute, and then C is hydraulic motor for nozzle, just visible at extreme right. Okay, hopper for plastic pellet, which is the above over here. And then the limit switch controlling the size and dwell time, injection molding particle dismantle. Stainless steel heater element leaning against cover under the ends of the injection nozzle. Okay, but when you go to industry, you might having more modern types of injection molding. But basically, their operating procedure, working principle is slightly similar. And then finally, the D part is the control panel. We have analog system, the old versions of injection molding. But nowadays, industry moving towards the more digitalized control panel, having some more detail in capture the parameters adjustment and parameter settings. This is the illustration of injection molding machines. We're having what we call that injection unit, and then we have the mold unit and the clamping unit itself. Injection machine function are: first one is to move the mold and compress mold closing, injection material into a mold and plasticize new batch. And the injection molding consists of injection system, mold system, clamping system, hydraulic system, and the control system itself. Okay, this is the injection molding illustration. I think I couldn't play this one, but it's okay. You have this slide, and later on you can play this illustration. And it's having the unit system that I mentioned earlier, the 5 unit: hydraulic, injection, control system, mold system, and the clamping system. And then for injection system itself, having a barrel, hopper, screw, heater, and nozzle. I think this one covered by PST371 313, the polymer machinery itself, but this is more on what we call a flashback, the knowledge that I've been transferred last semester. The clamping system having a toggle hydraulic and combination, mold system, single cavity, multi-layer and split mold, and then we have control system, the center of process control, hydraulic system, servo hydraulic system for pushing the screw itself. The injection system main function are to melt and plasticize the material, to inject material into the mold, to compose mold closing compression with compressed melt inside mold, and secure the mold from form copy on product. Injection unit parts are barrel, cylinder, hopper, screw, nozzle, and heater. Injection mold tool. The mold tool is the key component in the injection molding of plastic. It improves passageway for molten plastic to travel from injection cylinder, which is the barrel, to the mold cavity. It allows the material, allow the air which would trap inside the mold close to escape. If the air could not escape or vented, then the molded part component would contain the voids or the air bubble and have a poor surface finish. It cools the mold until it sets. The temperature of the mold is controlled because it is important for the molding cool at the correct rates to avoid distortion and stress. This is what I mentioned earlier, the slow injection molding, because we want to eliminate or to minimize the stress or distortion. In the mold system, water circulates through a channel drilled through a mold similar to a car engine cooling system. By means the ejectors of the finished molding is pushed from the mold. Okay, this is plastic mold tool. Here we have the number one. You can go through the illustration. Number one is guide pin. We have runner, screw, gates, and then screw bush, locating ring, mold cavity, and ejector pins. Okay, this is the component in mold system itself. And then we have a clamping unit, a closing unit move mold half towards the further each other. It also composes a closing force. Closing unit are divided into a mechanical, hydraulic, and hydraulic mechanical unit, which is the combination. Closing unit is the biggest part of injection molding machine. This is the hydraulic units. And then we have a control unit panel. Okay, injection molding process. Okay. So I think I stop here for the part 1 for chapter 3, and I will continue with the injection molding process. I will elaborate more detail the actual process of injection molding, and by so I hope to see you by next week. By then, Assalamualaikum warahmatullahi wabarakatuh. Thank you.